Oh, remember this is a typo. Okay, looking at that, my parent function, the original one, was x squared. Now I've got some changes that happened. Let me move this. So my original here was f of x equals x squared. I know that because of this little power right here. The one in the parent function that has a power of 2 is the x squared. So we're going to go in and we're going to look for our changes. We like this highlighter stuff, huh? So we've got this difference. That wasn't there before. And then we've also got this minus 5 inside. That wasn't there before either. So 2 differences to explain. Let's start with this one. Okay, I need to identify if it's outside or inside. This one's outside. Inside would mean actually inside the parentheses. Then I have to say, am I adding, subtracting, changing signs, or multiplying? Well, it's 3 times, so I'm multiplying 3 by 3. Multiply by 3. Okay, outside multiplying by 3. Multiplying is this page, right? Multiplying. Outside, so I'm doing a vertical stretch or a shrink. Well, it's 3, which is bigger than 1, so it would be a stretch. So this is a vertical stretch by 3. Oops. Okay, inside here, I'm subtracting 5. Subtract 5. And where am I doing it? Now you can see I've put those parentheses in because that separates the inside and outside. Now, bells and whistles going off on in your head. It's inside, which means it's some kind of horizontal change. And everything is always backwards. So going back to our reference, we are subtracting inside, which means it's a horizontal shift right. So we subtracted 5 inside, so it's a horizontal shift right 5. All right, this next one right here, you can see, again, you're going to have to learn to read your parent functions, but it's got an x up in the variable, and there's only one of them on there that had the x up in the variable, and that was the exponential. So f of x equals 2, same base, that part won't change, and the x was usually alone by itself. So identifying our changes. We've moved to pink. We've got this guy, he wasn't there before. I guess that's kind of purplish, huh? And then we've got this, which wasn't there before. Quit it. Okay, 2 changes. This one right here. Oops, I don't want that. I want a pen. I get delirious at some point, guys. Sorry. I don't want green. This right here, there's a negative and it's outside. It wasn't there before. It was just a 2. Now all of a sudden there's a negative outside in front of it. This one right here, we've added 3, but is it inside or outside? This one is inside because it's up in that power with x. If it was an outside one, it would have looked like this. See the difference between the two? So add 3 inside because it's up in the power. Let's write a note, up in the power. Power. You've got to be able to read it. So inside because it's up in the power. All right, let's describe these. So negative outside, reference sheet. Let's see, negative is outside, so it's a reflection over the x-axis. Over x-axis. Okay, And then we've added 3 inside. Adding inside happens inside, adding, so that means it went left. So adding inside, this means we did a horizontal shift, left 3. And those are the transformations. So what operation is it doing? Is it adding, subtracting, multiplying, or was there a negative sign involved? And then is it happening inside and outside? Those two things help you determine what kind is going. Look, it's so pretty and colored on and backwards. What's the operation? That's the main thing you're asking for. What's the operation that's happening? And then is it happening inside or outside? Okay, let's look at these graphs. This is comparing to your original functions, your parent functions. If you look through them, you'll see the graph that kind of looks like this is the cubed root of x, but normally it goes right here. I know you love my gorgeous picture there. So what's the transformation that's happened? Well, it's moved to the right 2. Horizontal shift, right 2. Okay, this one right here, if you look at it, your parent function is the square root function. And you can't tell very well by looking at it, but if you look at the parent function, it goes through 0, 0, 1, 1, and then 4, 2. So if you look at that, there's 2 options. You could say that it's a vertical stretch because I'm pulling it up, or a horizontal shrink. I'm going to go with horizontal shrink. And to tell by how much, you look at these other points. So 2, instead of at 4, 2, now it's at 2, 2. So the x has changed and it's decreased by a half. So it's a horizontal shrink. I don't even care on this one if you got the thing. If you just said horizontal shrink or vertical stretch, I would have given you credit for it. This one, if you look at your parent function sheet, this one is the rational function. Normally it looks like this, and it's got those asymptotes, and it's got these curves that look like that. Now you could use key points, but I think if you look at it, the easiest way is to find its new crisscross, its new asymptotes, and just describe how that's changed. So they crisscrossed here, now they crisscross here. That means it's gone down 3 and left 1. So we've had a horizontal shift left, I don't even care if you give me the amount, and a vertical shift down. So it's all about knowing what the parent looked like and comparing it to that original one.